In this video, we'll continue our discussion of section 4.4, undetermined coefficients. So starting off, how do I determine that is this method that we're going to use? Well, I have constant coefficients. All right, that tells me I can figure out a homogeneous case. And then if I take a look at everything on the right, these are the forms that I know will come out of the same forms, meaning polynomials make polynomials. Sines and cosines make sines and cosines. When I say make, I'm saying derivatives. And e to the x's provide e to the x's. So that's why we know that we can use this form. So first things first, our homogeneous case is going to be y double prime minus y equals 0. Okay, using the form from earlier in the chapter, we plug in our m's. This isn't going to factor. So what this turns out to be, quadratic formula, negative b. So that's 1 plus or minus the square root of b squared minus 4ac is just a 5 in this case, over 2. Now it's very tempting to go to the complex route, right? That imaginary route with the e's and the signs. But these are two real numbers. So the complementary solution here, and I make this mistake sometimes, so be careful. I get e to the, oh, don't forget your C1. Story of my life. C1 e to the 1 plus square root of 5 over 2 x plus C2 e to the 1 minus the square root of 5 over 2 x. All right, so there is my homogeneous solution. We'll use that later to come up with the general case. All right, so looking at this, if I'm going to come up with a guess for my particular solution, okay, I got a couple things going on here. I see that I have a cubic function, this thing. I don't have to worry about creating anything bigger than the cubic function because the cubic, it doesn't come out of these at all. So I'm just going to do an ax cubed plus bx squared plus cx plus d, which I'm not totally stoked about because that makes the problem pretty long. I also see a cosine, so I'm going to get e cosine x plus f sine x. That comes from that function. And then this next thing is going to be a pain as well, because I'm going to get gx e to the 5x plus h e to the 5x. Right? I have to get both of those because it has an x in it. These don't conflict with that because the coefficient in front of x is different. All right, so there is our absolute horrible possibility of a solution. The reason I'm saying it's horrible is because how long it is. I also got to get to the second derivative. Now, the thankful thing that I can say about this is at least everything, most of all this is separated by plus signs. So y prime of this solution is going to be 3ax squared plus 2bx plus c minus e sine x plus f cosine x. So I'm glad these are all easy. I do have to use a chain rule here. So I get g e to the 5x, or product rule, forgive me, 5gx e to the 5x. And then the last thing will be 5h e to the 5x. No product rule there. All right, I know I'm going to use that. So I'm going to work my way up to double prime now. So I get 6a x plus 2b. Okay, minus e cosine x minus f sine x. Okay, and then plus 5g e to the 5x. And then this is going to be a product rule, so I get 5g e to the 5x plus 25gx e to the 5x plus 25h e to the 5x. Sorry that I had to go below there. These are long. Okay, double checking my notes so I don't lead you guys astray. Everything's looking fine. Cool. I probably could put things together here. So let's go ahead and do that. YP double prime. You probably need to write small too. 6ax plus 2b minus e cosine x minus f sine x. And then I got plus 10g e to the 5x plus 25gx e to the 5x plus 25h e to the 5x. Okay, at least a little better. Now I'm going to try to build my diffie-q. Okay, I need a minus yp prime. Yes, okay, so I'm going to change the signs of all those. Negative 3ax squared minus 2bx minus c plus e sine x minus f cosine x minus g e to the 5x minus 5g x to the e to the 5x minus 5h e to the 5x. And then, oops, don't know what happened there. Then I need minus y, just y, p. So I'm going to subtract all that. Negative ax cubed minus bx squared minus cx minus d minus e cosine x minus f sine x minus g x e to the 5x and minus h e to the 5x. So now all I got to do is add those three together. Now be very careful. Like I said, this is where the mistakes happen. This is where you just need to make sure you slow down. I'm only adding the 3 down. All right, so I'm going to put things together. Okay, I got negative a equals x times x cubed plus negative 3a minus b times x squared plus 6a minus b minus c times x, and then last one be b minus c minus d. That's my constant. And then the rest of my equation, putting things together, I get minus 2e cosine x plus e sine x minus 2f sine x minus f cosine x. And then I got one last line here, 9g plus 19h e to the 5x, and then plus 19g e to the 5x e to the 5x. Oof, it's pretty long. So now I have my system here. So I'm going to plug them all in. I can compare this to up top. So negative a must be a 5. Negative 3a minus b better be 0. Sorry, my dog barked here. 6a minus b minus c is 0. B minus c minus d is 0. Negative 2e minus f is negative 4. E minus 2f equals 0. I got to move this up just a bit. Okay, 9g plus 19h is 0. And then the last thing, 19g, better be negative 10. So here's my system. You can make a matrix if you would like. I did use some online thing to help. No, I think I did this one by hand. You do not have to do that. So here we go. I'm going to list these off. A equals negative 5. B equals 15. C equals negative 45. D equals 60. E equals 8 over 5. F equals 4/5. G equals negative 10 over 19. And then H equals 90 over 361. So if you use your calculator, you're going to have to figure out how to get those back from decimals. You could just use the math track option. So we get y sub p. We got to write small here. I get negative 5x cubed plus 15x squared minus 45x plus 60 plus 8 over 5 cosine x plus 4 over 5 sine x minus 10 over 19 x e to the 5x plus 90 over 361 e to the 5x. All right, and then I ran out of room here, and I think we have it. Y sub p plus y sub c here, or we usually do it reversed. We do y sub c plus y sub p as our solution. So what I'm going to do is highlight this because I'm out of room here, and I think we can understand that we're going to put those together. And that's our last solution. To grab this y sub c, I'll highlight it up here as well to get our end solution there. So be very careful. There's a lot of moving parts. The calculator is probably your best bet with this if you can practice setting it up. This goes all the way up to H, so you're going to have a giant matrix. It's up to you on an exam. I'm not going to go through this much because this would take you a good amount of time, and there are a lot of barriers, algebraic barriers, that could stop you from showing the appropriate method. All right. We're going to do one more in this video. It's kind of a generic one. So if we go to that next problem. All right, so we have an omega, we have a gamma. So don't let it trip you up. So we're dealing with x. I can tell these are constant coefficients, omega squared. We're going to say the constant. So y sub c, that's our complementary solution, is going to be x double prime times plus omega squared times x equals the f naught cosine of gamma t. Oh, wait, we don't want that. We want the homogeneous case. So we want 0. Sorry, my brain was thinking about where we're going. So we m squared plus omega squared equals 0. Be careful, you don't get an m from that x. So m squared equals negative omega squared. So that means m is plus or minus omega I. That is a complex solution, so we're going to get the complementary general solution will be not C1 first. Well, it's going to be e to the 0 x. We'll go ahead and I guess write the whole thing. Then I'm going to get cosine, C1 cosine, omega t, plus C2 sine omega t. But we don't need e to the 0 x. So I'm going to leave it like that. We know that e to the 0 x doesn't need to be there because that's just a 1. So here's my guess now. Looking at that right side, I see that f naught, and it's just a cosine gamma. That doesn't fall into here, so don't let that trip you up. We don't need to add a t. So y sub p, or actually these aren't y's anymore. These are x's because the output is x. All right, so x sub c. Now we have x sub p. My guess is going to be a cosine gamma t plus b sine gamma t. Right, nothing too complicated there, thankfully. X prime, because we're going to have to work our way up to x double prime, is going to be negative gamma a sine gamma t plus gamma b cosine gamma t. We got to work up to our second derivative. All right, so that's going to be negative gamma squared a cosine x, or sorry, cosine gamma t plus gamma squared, or it's going to be a minus actually now, minus gamma squared b sine of gamma t. I have to build up, so I'm going to do that. We have that, and then I need omega squared times x sub p. So this is going to be a omega squared cosine gamma t plus b omega squared times sine of gamma t. All right, I can add these together. xp, yep. Right, adding those two lines, okay, I get my cosines together. So cosine's going to have an a omega squared minus gamma squared a. That's the, oh, be very careful. I think I made a mistake here. Cosines go with cosines, sines go with sines. Oh, we're looking right here. I almost made a mistake. Okay, there we go. We're good. So a gamma squared minus a, or sorry, a omega squared minus a gamma squared cosine of gamma t plus b omega squared minus gamma squared sine gamma t. Okay, following our method here, I know that we have a system that a gamma squared minus a, or sorry, I keep calling it gamma, a omega squared minus a gamma squared must be equal to f naught over, or not f naught over, but f naught, because it's in front of cosine. And then I also have that b omega squared minus b gamma squared is equal to 0. All right, what that gets me, you can factor out the a on top, and we're going to get an f naught over omega squared minus gamma squared, and then b is just going to be 0. So x sub p then is f naught over omega squared minus gamma squared times cosine of gamma t. All right, so we have our solution. Our solution is going to be c1 cosine of omega t plus c2 sine of omega t plus this whole thing, f naught over omega squared minus gamma squared cosine of gamma t. They gave us initial conditions, so we're going to have to use those. So I'm going to need an x prime as well. So I'm going to get a negative gamma c1 sine gamma t, or gamma omega, I'm just destined to call it that, I guess, times omega c2 times cosine of omega t. Those omegas are come from the chain rule. And then this last thing, we're going to get negative f naught gamma over omega squared times gamma squared sine omega t. All right, everything's on looking the right way. So now if I do x of 0 equals 0, I'm going to get 0 equals c1 plus f naught over omega squared minus gamma squared. And then x prime of 0 equals 0 is going to get me 0 equals omega times c2 plus, oh, that's it. So C1 is going to be that negative f naught over omega squared minus gamma squared. C2 is 0. So we get x to be C1. So it's going to be this negative f naught over omega squared minus gamma squared times cosine of omega t plus C2 is 0, so that's gone. And then I'm going to get F0 over omega squared minus gamma squared cosine gamma t. So there's my solution. So don't let the gammas and omegas trip you up. I guess, I mean, if you can get the names right, unlike me, but they work the same way. Don't let them trip you up. All right, we'll end the video here.